Squirrel cage motors are the most common of all three-phase motors. They got their name from the type of rotating member or rotor used in the motor. A squirrel cage rotor appears to be a hunk of iron with a shaft through the center. The rotor actually contains a set of bars shorted together at each end. Laminated steel pieces are placed over the bars to provide a good magnetic path. If the rotor is cut in half, you can see the bars inside the rotor. It's these bars that form the squirrel cage winding. The squirrel cage rotor gets its name from the fact that if the steel laminations were removed, the rotor would resemble a squirrel cage, like those used by pet squirrels or hamsters. The first thing you should understand about an induction motor is that it's basically a transformer. In fact, when Nicola Tesla patented the induction motor, it was patented as a rotating transformer. To understand how a squirrel cage motor operates, assume that a squirrel cage rotor is placed inside the stator winding of a three-phase motor. When power is applied to the stator winding, a magnetic field begins to rotate around the inside of the stator. The rotating magnetic field cuts through the bars of the squirrel cage rotor, inducing a voltage into them. Since the bars are shorted together at each end, a large amount of current will flow in the rotor. This current flow through the rotor produces a magnetic field around the rotor bars. The magnetic field of the rotor is attracted to the rotating magnetic field of the stator. The rotor begins to turn in the same direction as the rotating field. If the motor is not loaded, the rotor speed will continue to increase until it reaches a speed close to the synchronous speed of the field. The rotor of an induction motor can never actually reach synchronous speed, but at no load it can come very close. If the motor were to turn at synchronous speed, the motor could not develop any torque.